Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on December 21st, 2025, about 3 days ago. It finds a pretty stubborn human-AI difficulty misalignment, where scaling up model size does not reliably help, and models instead drift toward a shared machine consensus. Plus, they show weak introspection with ORAC around 0.55. The paper is titled, Can LLMs Estimate Student Struggles? Human-AI Difficulty Alignment with Proficiency Simulation for Item Difficulty Prediction. Okay, and the implications for using large language models in cold start educational assessment are quite significant. Also, the authors shared a companion GitHub repo for difficulty alignment. You will find the formatted datasets they analyze, plus a big dump of model outputs across tasks, models, and prompting setups, including proficiency simulation. They also include Python scripts to reproduce the main plots, tables, and problem-solving accuracy summaries. Figure 1 makes the core problem feel very concrete, because model difficulty predictions do not spread out like real student difficulty. This figure shows violin plots, which summarize a full distribution rather than a single average. The left column shows ground truth across 4 tests, and the model columns show much tighter shifted shapes. The collapse is especially visible in SAT reading and SAT math, where models cluster near one end instead of covering easy through hard, so rankings get distorted. Table 1 puts a single number on how well each model matches real student difficulty rankings. Spearman rank correlation measures whether 2 difficulty orderings agree, even if their raw scales differ. The whole table stays low, which means models often disagree with students about what is hard. The bottom average row shows USMLE around 0.13, while SAT math is higher at about 0.41. The model average column stays under about 0.44, so bigger or more specialized models do not reliably fix alignment. Figure 2 says that ensembling models only helps up to a point, so it cannot fully fix the mismatch with human difficulty rankings. Spearman correlation measures how similar 2 item orderings are, so higher curves mean better alignment. The red SAT math curve rises to about 0.66 around k equals 14, but it drops once weaker models get added. The blue USMLE curve stays low and gradually declines, which shows dilution almost immediately. Table 5 shows that most models have weak self-awareness about when they will get a question wrong. The metric here is ORAC, which measures how well predicted difficulty separates the model's own incorrect answers from correct ones, where 0.5 means pure guessing. Across the full table, the average sits around 0.56, so difficulty scores barely track failure. A few cells spike, like about 0.73 on Cambridge for GPT-5, but the overall pattern stays near random. Alright, 2 takeaways stand out. Large language models often fail to match real student difficulty rankings, and scaling up, or persona prompting, does not reliably fix that misalignment. The broader implication is that automated item difficulty prediction still needs grounding in student data and careful calibration, not just stronger models. That is it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.